right, welcome. We're in a new section. We're in Chapter 6, Section 4 now. And in case you think you're in the wrong place, we did skip Chapter 6, Section 3. It's not as important as I would like it to be, so I decided to skip it. So that's just further proof that if we're teaching you something here, we feel like it's important enough for you to know. Okay? So, for our first couple problems here, they're not actually in the notes. We're treating these kind of like bell ringers, but since there's no bell, unless you live in a very strange house, we're just going to go through them together here at the beginning of the video. So if you were asked, let's say, to simplify the square root of 60, you should have an idea of how that works. You would break down that 60, right? You would take your 60, you break it down into two numbers that multiply to 60. You could use 30 and 2, 4 and 15, 5 and 12, 6 and 10. I believe that's it. I try and pick two numbers that are close together for the factors. That way my tree is as even as it could be. If you did 2 and 30 here, you'd keep breaking down to 30 and you'd go like all the way down here. Okay, so I chose 6 and 10. We can continue breaking those down. That's 3 and 2 and 2 and 5. Okay, and I think those are broken down as much as possible. Since we've got a square root here, and that root is a 2, if there isn't a little root number there, it's a 2. That's telling us we can circle two things that are the same at a time. So on this bottom row, I've got two 2's here, so I could circle those. That means as a group, a 2 comes outside this root. So the square root of 60 equals, a 2 comes outside the root, and these numbers are left over. So inside the root, these get multiplied together. 3 times 5 is 15. So that's how we broke down square roots in the past. Okay? If you've got a pair of numbers, they come out. Anything left over stays inside the root multiplied together. So, the thing about this section is, what if I told you you could break down things that weren't numbers? Interesting, right? Let's go ahead and simplify the square root of x to the 4th power. The square root of x to the 4th power. We could do this. It's a similar idea as to what we did here. The thing we're breaking down is x to the 4th. Okay. So, and remember, if there's no root number here, it is a 2. So what we're trying to do is we're trying to be able to write this when we break it down in such a way that there are two things that are the same. That way we can pull them out. So how can we divide x to the 4th? Well, we could make it x squared times x squared, right? And if we wanted to, we could keep going and break this down. This is x times x and x times x. It's not really necessary to break it down all the way down to here, though. In this case, we can circle any two things that are the same on the same level. So we could have actually stopped here, circle our two x to the squareds, or two x squareds, and just said, hey, the square root of x to the 4th is x squared. Okay. If you wanted to break it down all the way to this level, it works the same way. You would circle every two things that are the same, so you'd circle an x here and an x here. And so that means you're bringing outside x times x, which is also x squared. So it works either way. Okay? Pretty cool, right? The same idea that we use to break down numbers, we can also use to break down letters to a certain power. Okay? So if this is still a little confusing to you, That's perfectly fine. We've got several examples here. There are even more in this section. This is just the first few. So let's see if we can get you a little more comfortable here. This is the first example that is in the notes for 6.4. Example 1a is to simplify plus or minus the square root of 16 times x to the 8th power. Okay. The first thing I want you to realize is under the square root we've got a number which we can treat this way. And we've got x to a power which we can simplify this way. So let's go ahead and see what we can do here. The plus or minus that's out front is going to stay with us the whole time. This is going to be in the answer. Okay, so we're not going to concern ourselves with the plus or minus. When we get what the square root of 16x to the 8th power is, we're just going to tack that plus or minus on right in front at the end. So let's treat this as the square root of 16 times the square root of x to the 8th. That's one of the properties of square roots. We can take something like this and break it up into these things separately. So essentially what we have is a problem like this and a problem like this, but in the same problem. But we can do each of these. You might know what the square root of 16 is off the top of your head. It's 4. Okay. If you didn't know, you could break down 16 into 4 and 4, circle them, bring it outside the root, and there's nothing left over, so it's just 4. Now, x to the 8th power, we want to be able to break that down as well. How can we break down x to the 8th power? The most common mistake I see on a problem like this is that someone might write x to the 4th and x to the 4th. The two things you write here have to multiply to x to the 8th. And actually, I said that was a mistake. This is actually right. The mistake would be if you wrote x to the 4th and x squared there, because 4 times 2 is 8. Remember, and I just forgot this because, you know, crazy things have happened. Okay, x to the 4th times x squared, if you want to know what that is, if we're multiplying these two things, we would add the exponents. These things actually multiply to x to the 6th power. Remember, we add the exponents. So the best way to get 8, in this case, is 4 and 4. Now, you could keep breaking these down even more, right? X to the 4th, we already broke down here. We could do all of this. But remember, we just want the square root here of all these things. So we only need two things that are the same to circle and pull outside the root. So since we've got 2x to the 4th here, let's just stop, circle those, and say, hey, this is x to the 4th power. Okay, so we've got 4 and x to the 4th. We're multiplying these things together. So we've got 4 times x to the 4th, which is 4x to the 4th power. And we said that we were going to put this plus or minus in our answer out front. Ooh, yeah. Plus or minus 4x to the 4th. Right? So, if that went a little too fast for you, I admit I'm doing this a little faster for this video than I would if we were in class together. But you do have the ability to rewind and pause this video if you need to go back through the steps that we took. Okay? But the main idea is if we've got a number out front and then a letter to a power, you can split that into the number by itself and then the letter to the power by itself and break them down separately. That's a great first step. From there, you have to go through some of these steps to get to the answer, but what is best is to be able to start a problem like this by splitting it up. That is a super important step. Okay, so let's do another example here. Example 1b. We want to simplify negative the square root of q to the 3rd power plus 5 to the 4th power. Okay. So I'm looking at this, And the first thing my eye is drawn to is this negative sign out front. This reminds me of this from the problem we just did. We said anything out in front, any signs, we would just put in our answer. That's going to happen here too. So we're going to take this negative sign and we're going to make sure it goes in our answer. Okay. So now that we know what we're doing here, we're taking the square root of q to the third plus 5 to the fourth power. I'm going to go ahead and write a little 2 here for my root. You can do that anytime there's a square root. I've done it every single time I've seen it here. I've always written 2's where there wasn't a root there. It won't always be a 2, but if there's not a number there, it's a 2. And what some people might do when they see a problem like this for the first time, they might think they have to take q to the third power plus 5 and multiply it by itself 4 times, because that's what this is. That's going to be really messy. I don't want to do this. I have better things to do, even during quarantine when I'm stuck at home. I've got better things to do than multiply this out and see what it equals. I really don't care. You'd have to FOIL this out. You'd have to FOIL this out. And then you'd have to multiply what you get for both of them. No, we're not doing that. Okay? We're not doing that. No. There is a shortcut for problems like this. This problem right here is actually really similar to this one. There are a lot of similarities. We see that they're both square roots. And inside the square root, we have something raised to the fourth power. In this problem, it was just x. In this problem, it's something a little more complicated. But the fun thing about problems like this, it doesn't matter what's in here. We're going to treat these problems exactly the same way. We could take q to the third plus 5 to the fourth power. And break it down, just like we broke down x to the fourth power over here. Okay. X to the fourth power broke down into x squared times x squared. Q to the third power plus 5 to the fourth power can be broken down into this squared times itself. So we're essentially saying this is the same thing as x. This to the fourth power is the same as this to the second power times this to the second power. So in terms of finding the square root, we need two things that are the same to circle. These two things are the same, just like they were over here. We can circle them together and bring one out. We're bringing one of these q to the third plus 5 squareds outside the root. There's nothing left over here. We used everything, so there's nothing still inside the root here. All we have to deal with is this minus sign. We put it out front. Okay. Not too bad. Okay. Once you know the trick, you can do that. In fact, you don't even have to write out this step. What you might notice on both of these problems, if you take this exponent and divide it by the root, 4 divided by 2 is 2. Does that always work? Here we had x to the 8th power. 8 divided by the root of 2 is 4. So if you've got something raised to a power inside a root, take the exponent and divide it by the root to get the exponent of your answer. Just saying. Can save you a lot of time when you're working on problems like this. Okay? So we'll keep a lookout for something like that in these next couple problems. Let's tackle the next one. All right, we want to simplify this now. Plus or minus the square root of 9x to the 6th power. Okay? You might want to pause the video. And if you're working through these on paper, which I recommend, what are the first one or two things you want to do when you see this based on what we've done here? We know that plus or minus is going to be in our answer, so we can leave it there for now. And I would write that 2 in the root for that. Okay, so we've got 2 as the root there. So we can break this one up just like we broke up this one. We've got the square root of 9, and we've got the square root of x to the 6th. Go ahead and write those 2's in the roots there still. You probably know what the square root of 9 is. It's 3. And here, you could break down x to the 6th if you wanted to, like we've broken down, say, x to the 4th over there. But what was our trick that we just learned? We can take this exponent and divide it by the root. 6 divided by 2 is 3. That tells us that's going to be x to the 3rd power. If you don't believe it, x to the 6th can be broken down as x to the 3rd times x to the 3rd. Circle those, and it comes outside the root. Nothing left over. Okay. So we've got 3 times x to the 3rd. That's 3x to the 3rd power. Don't forget your plus or minus sign. All right. Cool. This is the last one. So on the notes, this is B. This is answer B. B. I need to go back and learn how to write my capital B's. That's pretty bad. This is why I'm a math teacher. Let's simplify this one. So the one thing I want you to see when you first look at this one that's different than all the rest is this 5. We're not taking the square root of these numbers anymore. We're taking the 5th root. So what does that change in terms of how we do the problem? These 2's always meant that we circled 2 of the same thing. Or, in the case of what we did here, we take this exponent and divide it by the root. Now that root is 5. So, we'll keep that in mind as we do this. This has a number in front, x to a power, and y to a power. That's also different. We've only ever dealt with x's. Now we've got, or a q here, but now we've got 2 different letters. That's okay. We'll split this one up into 3 pieces. So let's take the 5th root of 32 times the 5th root of x to the 5th, and then separately we'll take the 5th root of y to the 10th power. So we'll deal with each of these separately. Now, the 5th root of 32, it's okay if you don't know that off the top of your head. It's not quite as easy as the square root of 9 or the square root of 16. Okay? But if you don't know what this is off the top of your head, that's when you break it down. 32 breaks down into, you could do 2 and 16, 4 and 8. 4 and 8. 4 and 8 will work. I think that's it. Yeah. And then these numbers break down even more. 4 is 2 and 2. 8 is 4 and 2. And then the 4 breaks down into 2 2's. Put everything on the same level. And you should end up with 5 2's. right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Got 5 2's here. So, how many things do we circle at once? If you said 2, let me point you right here. This is where the fifth root comes into play. We need 5 of the same thing to circle. Look at what we got. It's amazing when it all comes together like this. We're going to circle all 5 of these 2's. And they all come out as a single 2. Because we have one group of 5 2's. And there's nothing left over. So the fifth root of 32 is 2. Fifth root of 32 is 2. We move over here. If we have a variable to an exponent, we'll use the real shortcut. We'll take 5, the exponent, divided by the root 5. 5 divided by 5 is 1. So this is just x to the first power. And we usually don't rate the exponent if it's a 1. This is just x. So this is 2 times x. And then for our last part here, we'll do the same trick. The exponent 10 divided by the root 5. 10 divided by 5, that's 2. So that tells us that is y squared. So we're multiplying that by y squared. So this should be 2xy squared. Is that right? Looks good to me. 2xy squared. And in your notes, that is answer A. Answer A. Okay. So, again, what we learned in this video, we reviewed how to break down roots for numbers, okay, and learned that we can also do that now with variables raised to powers. We learned how to do that in general, and we also learned how to do it using our little shortcut here. Okay. And we've gone through several examples of what this looks like, and these aren't just the same problems, these are quite different in how they are constructed. So now you've got several examples that you can look at in the future when you've got a problem set with questions like this. You can either go back to this video, rewatch it, or if you've written these down in your notes, which I recommend, you can use those notes to help you with those problems. Should be pretty helpful. If you need to look through this video again, feel free to do that. If you have questions on these problems or any others that we talk about, feel free, please, please, please email me. Okay? It's really the only way that I can get your questions answered. It's as close as you can get to, in class, you're working on your problems, raising your hand. That is the best way to get help. Raising your hand here is just sending me a short email saying, hey, I was looking at this problem on this assignment, I'm confused. I will get back to you and help you out best I can, promise. Okay, so look forward to the next video that you'll get on your next e-learning day. There will be at least 2 more videos on this section before you have problems to work on. So you've got some time before you have to work on those problems. Okay, but for now, we'll see you next time.